Question 8. A teacher would like to know which of two homework incentive plans is more effective. To do so, she randomly assigns the 60 students in her class to one of two incentive plans by having each student flip a coin. Of the 34 students that were assigned to Plan A, 23 successfully completed all homework assignments. The remaining students were assigned to Plan B, of which 20 successfully completed all the homework assignments. Okay, so the size of Group A was 34, and the proportion of that group that completed homework was 23 out of 34, which I'll figure out the decimal later. Okay, the size of Group 2, 60 minus 34 would be 26. And then the proportion of Group B that completed homework would be 20 out of 26. Okay, the teacher would like to construct a 90% confidence interval for PA minus PB, which would be the true difference in the proportion of all students like these that would successfully complete their homework assignment under the two plans. Which of the following conditions for inference, if any, are not met? Okay, so this is a question about conditions. There's usually three conditions that we want to check when we want to create a confidence interval. The first is the random condition, meaning that our data come from random samples or from an experiment that uses random assignment. Okay, looks like that's been met, right? The teacher randomly assigned the students to groups. Okay, all right. The second is the 10% condition, all right, which only needs to be checked when you sample without replacement. Since this is an experiment and doesn't involve sampling, the 10% condition doesn't apply in this situation. Don't need to check it. The third is what's called large counts. Right. And the reason why we check the large counts condition is to justify the use of using normal distributions. Okay. So the random condition has been met due to the random assignment. The 10% condition is not needed. The large counts. All right, so let's check. We need to make sure that NA times P hat A is greater than or equal to 10. NA times 1 minus P hat A is also greater than or equal to 10. NB times P hat B and NB times 1 minus P hat B. Right, all four of those quantities need to be 10 or more. Okay. All right, so let's check the first one. This is going to be 34 times 23 over 34. So here's the beauty of leaving it as a fraction, right? You can do the math in your head, right? The 34s cancel, you get 23. That's bigger than or equal to 10, right? And do the next one. 34, 1 minus 23 over 34. Now, that's going to be the same as, well, what's the difference between 23 and 34? It's 11 difference, right? So that's the same as 11 over 34, which when you multiply gives 11. Okay, that's 10 or more. Okay, next, this is going to be 26 times 20 over 26, which is exactly 20. Check. The next one is going to be 26 times 1 minus 20 over 26. And the difference here is going to be 6 out of 26. Right, so I'm just thinking, well, 1 is the same as 26 over 26. Common denominator, difference of the numerators is 6. All right, so that's 6 over 26, which then becomes 6, and there's our problem, okay? That's not 10 or more, okay? So the large counts condition has not been met. Okay. All right, so random condition is the only one that's not met. No, that was met. The 10% condition is the only one that is not met. It's not needed. The large counts condition is the only condition that is not met. I believe that's the correct answer. All conditions for inference are met. No, both the 10% condition and the large counts condition are not met. Okay, so the 10% condition is not needed. So it's not that it hasn't been met, it's just not needed. All right, so I think C is the answer.